Thank you. Applause at the first and beginning. Thank you so much for that. So once again, welcome everybody. My name is Florian Hettenbach. I'm a technical trainer with Amazon Web Services. Typically you might engage with freelancers from AWS. I'm an employee, so I work for Amazon Web Services. And today I want to give you an impression a little bit, really a small scratch across the surface about serverless architectures. I heard already that you had already a talk about Lambda. Who knows Lambda already? Just give me a show of hands. Okay, so we can skip Lambda, or I can come back to you with any more detailed questions, right? It is important. So from a technical perspective, just to set your expectations straight, this is, I would say, a talk 150 to 200 level. So we have typically this 100 level, very basic, very overall, very general, and 400 level where we go really deep. So this is 150 to 200. If you now have something on your plate on a project that you want to migrate to AWS or run in a serverless architecture, please use the platform slido.com, put in the code LOG, of course for League of Geeks, for your specific sniper type questions that you would like to ask me. Typically, I'm most of the time capable to answer questions, but it's sometimes also the case, as we have such a broad platform and we have so many services we're offering and we're innovating at such a high pace, we can't know everything, and I can't know everything. That's kind of the biggest challenges when you move to cloud, that you find out there is just too much to learn. Okay, good. Let's dive into the topic. First of all, where do I come from? I had already the introduction, so I come from Regen, 65 kilometers away, and I've always been in the region. I started my internship in a professional school in Deckendorf at a company. I had my professional internship here in Passau. I then worked 8 years for a server manufacturer in Freyung. Did technical support there, product management, virtualization, a lot of stuff, and I came from a totally different world. So, oh, sorry about that. This was my world. Back in the days, this was still CBIT, already passed, where I worked with components that you can touch. So I'm admitting this openly, I'm not coming from the development perspective. I'm moreover coming from the solution architect, building solutions, consulting with customers and trying to find the best solution to solve their business problem. And I must say, comparing this small company where I worked with and people asking me now what it's like to work with AWS, I must say it's really close to working in a startup from an environment, from a cultural perspective. If any of you are students from the University in Passau, I also have tomorrow a talk at 10:15 about the innovation culture in AWS and Amazon, and specifically if you're interested. So let's dive into it. I want also, as I'm a technical trainer, I want to give you knowledge. I want to give you information that you can use after the training to come back to consult further. And I want you to learn. That's really important for me. So I'm always starting with this really simple example here. Everything starts with AWS.com. All of our resources compared to traditional technology providers don't have any marketing BS included. And I know this, I worked in technical product management, that typically when you're interested into those nitty-gritty details that you typically are scratching on the surface from all the marketing stuff. Use our platform and it will give you additional links that you can dive deeper into the topics. Okay. First of all, in the terms of why AWS, why the cloud, what is the important point about this? What's also the hype about it? I used this quote from our website, which says, whether you're looking for compute power, database storage, content delivery, or other functionality, AWS has a service to help you build sophisticated applications with increased flexibility, scalability, and reliability. Yes, one important point I also highlighted here is helping you to build. It's like, and this is the picture for me it more resembles with, the Lego blocks, the building blocks, which you can choose. And for me, AWS, it's not about technology. All the stuff we're using, it's not about technology. It's at the end, giving you tools to create cool new solutions, the new cool thing that disrupts an industry in the future. And also to play, to experiment, without incurring any high costs. And we are very transparent in terms of sharing information on how to use the platform and how much does which service cost. And I want you to keep this in mind, because this also leads to challenges. You see those, when we look at those stores, yes, we have managed services that help you get rid of this so-called undifferentiated heavy lifting. Because you always need to think about yourself, about your job. Is it really what you're currently doing in your company, differentiating your company, your overall organization towards the end customer? If not, I would think about changing this job role, or changing or adding more value to the company. And this is a change I specifically say when I'm doing trainings in Germany, that we're really hard in changing this, because change is something hard for all of us humans. It's not about the technology here. Keep this in mind. We also have building blocks, Lego blocks that don't have connectors on the top and the bottom, but connectors on all sides. This means when you create a solution today, your colleague tomorrow or next week could build the same solution for the problem with a totally different building block combination, which is totally valid. Or that we bring out a service 2 weeks later that makes this building block by block obsolete. Let's dive deeper. Also from our services, we have now 23 categories. And I brought this example in the quote when you saw it, meetup description, which it's like a roller coaster. It feels also overwhelming. You start into the platform and you do not know where to go. One really important link I want to highlight is aws.com/getting-started. This is our main page for getting started on AWS. And 165 services, evolving all the time, innovation from an innovation-based perspective, with round about 4 to 5 new services, new features, new additions to existing services per day. And it's just impossible. It's so fast. The innovation pace is so fast that also we are struggling to keep up with, to try to at least know the service, oh, that's a new service coming up, what does it do in overall, how does it solve the business problem? Let's dive deeper. We are now today talking about serverless, therefore aws.com/serverless. I will also show you a short demo how to create a solution quite easily in just, I would say, if you're fast, 30 minutes, if you take your time, 1 hour, 1.5 hours, with incurring around about 5 cents on the platform, a complete serverless solution to create an Uber-like service. Okay. Good. Serverless principles, what are there? So, no servers to permit it to provision or manage. Of course, when we talk serverless, there still are servers somewhere running, or micro VMs or containers running, but we don't need to manage them. Scale with usage. Serverless really takes off when you have these spiky workloads, where you do not yet know how much user traffic you can expect, how many people will use your application or your service. Never pay for idling resources. That's the core business problem it solves. Because when I'm still looking at those traditional customers buying servers, creating virtual machines, you over-provision all the time. First of all, most of the time you get a budget and you use this budget as good as possible. So you put in more RAM or more CPU in the physical server or into the VM, but typically you don't utilize this one. That's just how everything goes in a traditional way. Availability and fault tolerance built in. Remember, I always have this conversation in the training. HA, high availability, does not equal fault tolerance. If you have questions to those, feel free to get to me in the networking session and we can talk about this more in detail. Good. We also talk about this event-driven architecture, meaning I only incurring cost, I only talk to my, let's say, venture capital company that gives me money that I do not need to have this 1 million to build a data center or to build an application. I'm only incurring cost when I have users. I can scale by that, by creating a serverless architecture, and pay by usage. We also have a so-called free tier that is available for mainly all of our services that you can use to run, as an example now from the server side, 750 hours of compute for free. We have a service under AWS, a overview from all services that are either free forever or free for 12 months under aws.com/free. As simple. Good, a few fundamentals. I want to bring everybody up to speed in terms of having the same knowledge, the same understanding of systems. When we talk about IT systems, we have standard components, we have fundamentals in there. And typically we start off with compute. When we think compute serverless, you already heard the Lambda and heard the service, and you know about this one, is Lambda. Our function as a service, our service that you can use your application code and only execute it when there is a user accessing your application, or when there is an API call towards that. Storage? Yes, S3. One of the first production grade service initiated 2006, which gives you an ideal space for your static content as an object storage, which scales unlimitless, where you can upload objects and interact with this also in a serverless way. You don't create or don't purchase a storage system. You don't tell S3 how much storage you want. You just tell it, please give me a space where I can put in my data. That's it. And database? DynamoDB. Our NoSQL database that is used for most of the architectures. Doesn't mean that, as we are giving you example, that this is the best choice for your architecture. But DynamoDB is used as you only create tables in there and interact with those. You tell us how fast the database, how fast the table should react from a read and a write perspective, and we deliver on this mentioning you give us. Okay. Those are the fundamentals. Let's dive deeper into Lambda a little bit. So how does Lambda work? Overall, it's fairly easy. Lambda lets you run code without provisioning or managing servers. You pay only for the compute time you consume. There is no charge when your code is not running. To give a few more details, when you upload your functional stateless code, important here, that one Lambda function, which is at the end the container for your functional code, can run up to 15 minutes. You pay per the resources that you align to the function, depending on the memory that you give it. This is in combination also with the CPU ratio. And for the time it runs, built in 100 millisecond increments. How it works? So, we upload your code, either use directly code, or you can also combine this with Cloud9, our integrated development environment. You set up those triggers. So Lambda, as we will see in the demo, it always has these two-folded areas. It has these triggers where you said, okay, if something is inserted in my DynamoDB table, then I want to execute this Lambda function and perhaps store the data in S3. So it's always kind of pipe that it flows through, where you define triggers. Remember, event-driven architecture. This is a typical example where we also say, well, you upload a picture and you want to resize it for web, you want to put it in grayscale, you want to do anything else, or you want to send it to recognition for image tagging. Then you use a Lambda function to execute on those different layers and then store the data in, for example, S3, when we talk about static content, as an example. Good. And at the end, just pay for the compute time you use. Good. Supported languages, Java, Go, PowerShell. We also have now included a function called custom runtimes, where you can now, we always call it, nearly every programming language that you use, you can combine this with Lambda, called custom runtimes. Also Lambda layers. When you have already experience with Lambda layers and you reference certain dependencies, certain libraries that you typically need to duplicate into your function, you can now put this in a Lambda layer and have one reference point to that. That's just a few announcements we had at reInvent, our global customer-focused, Las Vegas-based event. More fundamentals here when we talk about serverless. So as you can see, serverless is also, well, what is serverless? We just consume a service. We just use the service and put our, let's say, IP or our intelligence in it. API gateway is a fundamental part where you can create your own APIs, you can version them and combine them, acting as your front door towards your infrastructure. Next service is also CloudFront, our content delivery network that can use not only AWS as origin, but also your own HTTPS server that creates a globally spanning content delivery network, also in combination with Lambda and CloudFront, our edge locations, where you can run Lambda close to the customer by using Lambda at edge. And also I mentioned here Kinesis, because Kinesis is our streaming service where you can use data streams, analyze them, put them into different outputs, and react upon those as a advantage to, or as another combination of using queuing services with Kinesis. Kinesis Streams, Firehose, data analytics. That's still scratching the surface. So there are a lot of more fundamentals. It's always important to have this kind of, also from an infrastructure perspective, in your application environment, this idea of having your core business logic, having your storage layers, your database layers, and at the end, your user layer, your presentation layer, your front end, that we have services to support those different layers in different ways. Good. Bring those all together as an example. How could this look like? So we started with content delivery with CloudFront, our content delivery network. Typically, this is used in combination with S3. Also because when we talk about traffic costs as an example, those traffic from S3 to CloudFront is free of charge. If we want to talk about pricing, if you want to learn about how are things priced, there is everything on the website. There is even a so-called simply monthly calculator for you to use. Just go to aws.com/pricing or aws.com/service-name/pricing. We made it easy for that. Next one, API layer. Use API gateway. I will also use this in the demo. The application layer resembled by Lambda. You might not say, well, if my code is not stateless, if I want to run this in parallel, if I want to have a failed state, etc. We have a service to cope with that in a few slides. The persistency layer, typically used with DynamoDB, because with DynamoDB we can scale easily. We don't need to think about vertical scaling, so putting more CPU and RAM into a server or an instance, but scaling horizontally, adding more nodes in the background to cope with your performance needs. From a serverless perspective, when you create serverless web apps, you typically use this combination here. This is an example we also typically give to customers, where you have your web browser in here, you have your user sending you HTTPS access via CloudFront, accessing this either locally or somewhere in the world. Dynamic content via Lambda, static content via S3, and also for dynamic content that is maybe session data that you want to move up of your web server so you can scale and build a highly available system as an NoSQL data storage. We'll come to this if you're now thinking, well, if NoSQL is fine, or but I'm currently using relational databases. We also have a service that gives you kind of a relational database management engine, but with a serverless flavor. Another use case we have here, I already talked about this one, is this image uploading and this further processing of images via Lambda. I mentioned recognition, our service where you can tag either video or also photos to be recognized, let's say mountains or people in there. Also, are they happy or unhappy, and further react upon those. Or use this as a typical website. I know this from another customer, where they use this to recognize any, let's say, illegal stuff that is uploaded via their website. When they say, if we have any pornographic material as an example, to recognize it automatically and filter this out so it does not come to the platform. That is, that it does not consume storage space at the end. IoT backends is also a good example here, where you use IoT sensors. You might use here additional services we have in the IoT sensor, but typically it runs off that you stream those data from your tractor that is running on the field and perhaps needs a replacement part to Kinesis Streams, where you capture all this data, once again fire off the Lambda function. It's not complicated, it's quite easy to start with. And then output an order and perhaps send this replacement part automatically to the person running the tractor. Let's move forward. Now serverless, we also have SAM. First of all, meet SAM. I've also brought SAM with me in form of stickers. So if anybody is keen on stickers, please come back later on in the networking session. I brought Sam with me. So Sam, what is Sam? Sam is our serverless application model that we use typically. I see 80% of the people building application, building stuff, solving the same business problems. So it might be a good idea to use some form of templates to be reusable, to not invent the wheel again. We use SAM as a template to define those serverless applications. We typically work here with CloudFormation to create those applications. A little bit more detail here how SAM works. So typically you have those scattered environments. You see we have Lambda, we have API Gateway, we have storage, but at the end the components remain the same. They are just reused in a different way. So why not use also perhaps blueprints to create serverless applications without inventing the wheel. So having these different layers and combining those together. Standard model for us on serverless applications. You can combine different functions, event sources and data stores. Yeah, at the end it simplifies stuff. Gives us a template. More on that, natively supported via CloudFormation. Those of you who did not yet come across CloudFormation is our infrastructure as code service where you describe the stuff or the stuff I've seen back in the days in those data centers physically into code and make this reusable, but also implement logic that you say, well, if I'm deploying this CloudFormation template into a development environment, I only need a single database. If I'm deploying this to the production environment, the database should be automatically highly available. I should have more web servers available. I want to have a certain engine for the load balancer in different ways. So this is where we use CloudFormation. You can export also any function as a SAM template, package those, and you can create community extensions for that under Apache 2.0 as a license. Also, this question always comes up, well, yeah, if everything runs in the cloud, how do I debug my code? How do I run this stuff? I don't have AWS in the pocket and can try it out. I don't have a good internet connection while I'm traveling via train. That's totally feasible. Use our Lambda CLI for that to run locally and debug locally, to test this out. The CLI tool, yes, for running those. We have those proxy styles APIs that you can use to program against and test against, and supports all those native runtimes that you saw earlier in the slide. Okay. Good. Also helping CI/CD when we talk about continuous integration and continuous deployment. When you have this DevOps approach in your company and say, well, we build it, we run it. You can also use SAM in combination for that. Where we look at CoPipeline, which is another service. If you're interested, if you say, well, this is interesting, but I'm just a developer. I just want to learn about the developing stuff on AWS. aws.com/developer. Everything that starts with code, that's typically developer or DevOps related. So you can use on the commit side either GitHub, you can use code commit, you can use code build here in combination with those, test those with either code build also or with third-party tools, and deploy this via CloudFormation. That's the typical workflow we're having here. Please keep in mind always, when we also give you recommendation, when we see, well, we are seeing that this works at customer environments, doesn't necessarily mean that it's the best solution. We always say we're not the prophet. I'm not the prophet coming down from the mountain with the 10 amendments carved in stone and telling you what to do and what is now wrong and what is right now or wrong that you've done in the past. It's not about that. It's about giving you choice, showing you the Lego blocks, okay? How you use them, which color you use, which different types, this is up to you. We can give you guidance, we're here to help. But please, ask, okay? Ask questions. Come to us. Or come to the events. Step functions is the other service I want to bring your attention to. When you want to run Lambda now in a form with state, you want to create state machines. You want to preserve this state throughout your application, and you want to run Lambda in retrial, in parallel. Then use step functions. They are typically used to create a serverless workflow. We have had a service back in the past called Simple Workflow Service. This is now the predecessor for that. You build and update apps quickly, and what I really like here, you have something tangible. You see what you're doing. You have kind of this workflow in the AWS Management Console visible how it flows through. Well, you can use, of course, Lambda together with ECS, Elastic Container Service, use your Docker containers for that, and deploy complex solutions. How this looks like, just an example here, where we have, this is just a screenshot to give you a little bit more insight how this looks like from a console perspective. I always give this input. When you see screenshots of AWS consoles, this might already have changed. This doesn't mean that the functionality of the service changed, but the GUI has been updated. We also, typically I'm also really surprised when there is a new update, because I don't get all the updates we are doing on the platform to be informed when I'm having a talk. So don't worry if this looks a little bit different, the structure remains the same. To give you this example here, don't worry, we will distribute the links after the meetup, so you can do your research and dive deep into those topics. We have this example. We want to extract metadata out of an image. We start off on the top with a task. We define the starting point. We have a choice between, well, not supported. We have a failed state here. And within the storage image metadata, we take this in parallel, create the thumbnail, and use recognition to add tags for that. How this looks like from a service perspective, you always recognize this icon for step functions. Another example I want to give you, which I find really interesting, when you're looking, well, you want to create a new YouTube, you want to create a new video on demand platform, where you have perhaps the challenge to have a platform where your users upload videos, you convert them, you do stuff with them, optimize them for mobile, and then spit them out at the end. This is something you can fairly easily do with step functions, so for ingesting, for processing, for editing, and then at the end saving it to a S3 bucket as an example, or just use Elastic Transcoder, which gives you one complete service where you only specify where are the static videos stored, how should they be processed and outputted into which S3 bucket, hit the button, and you only pay for this transformation, this conversion. This was an example where we still had a lot of discussions about step functions with customers, where there already was a service that makes this stitching together of small components obsolete. Good. A few examples here. So also for Lambda, at the end, it's event-driven compute service. We talked about this one. It's the steps. You upload your code, or you specify where the code should come from. You run your Lambda function in parallel, and we are making sure that we are scaling efficiently for you. Good. Lambda can also work as a mobile backend. We will see this in the demo with API Gateway. And also perhaps here use SNS, simple notification service, where you can then, it's a pub-sub architecture where you have subscribers to a certain topic that you push out to a notification via your mobile devices or via email or via SMS. Don't confuse SMS and SNS. It's those SMS via SNS. I know, it's crazy. It's so many abbreviations, so many abbreviations. Good. Also DynamoDB. Yeah, we typically have, with Amazon.com being our customer, a lot of examples where somebody shops at an online shop, places an order, and this runs through a certain workflow. Yes, it's somewhat related. And use DynamoDB to store the data, trigger Lambda, and put the stuff in a columnar database called Redshift to use as your data warehouse. And use as a system to hold your data to be further analyzed with business intelligence tools. Typical warehouse example. Good. Now, let's dive into the demo. What I brought for you is, so I would show you how to build a serverless web application with AWS Lambda, Gateway, S3, DynamoDB, and Cognito. Fairly easy. Not really hard. It's great because we are also providing you with a lot of projects, with a lot of tools to play around. Typically, you do not need to code. You always can code, but you don't need typically to just get started with the service, to just get your hands dirty and look at this, how it works. Okay? Good. So, I see I need to speed it up a little bit. What we will do, so the application at the end looks the following way. We are using, of course, a web browser to access our application. We have our stuff stored in S3 at the end, which is where we can enable S3 not only to hold our data, but to create a static website that can be made dynamic via using JavaScript. We will do this here. We use authentication now. Cognito, another service we did not yet talk about. Cognito is a great service for authentication and authorization for mobile apps, on mobile users, where you create identity pools, where you create user pools. And for example, after they register, they should get an automatic authentication token that is handled via Cognito as a service. And dynamic API calls, we use API Gateway here, Lambda and DynamoDB in the background. And to make it more fun, we're not just creating environment, but we're creating this application called Wild Rides, where you can order your, but you can order a certain unicorn to a location to be picked up upon. So a unicorn-styled Uber app in that case. Good. So I did the demo yesterday. So what I made to be independent of any problems in terms of the internet connection, I've made a video of the demo and I will guide you through those. We will not watch the video entirely. Let's just double check that the screen looks good. But I will guide you through those most important steps. Let's do it. This looks good. Can everybody read it? Is it okay from the back end here? Can you read it? A little bit too small. Sorry, I cannot. Bad question, right? Can I improve the resolution? I should not have asked. Sorry about that. Sorry about the last row. Just come in front. Come closer. Come closer. Okay. So I just want to get started here. Let me just double check. I need to restart the video here. Let's do the following. And restart it. There we go. So if some of you did not yet occur or used AWS, this is the AWS Management Console. It is important. Everything you see on the graphical interface, you can also script. Everything in AWS is an API, so you can script everything. Meaning, what the stuff you do in the interface, you can also script. You can also just use an API for that. Okay. Sometimes so a lot more that you can see in the Management Console. Where do we start with? So remember, we talked about our data in S3. We had API Gateway to access our application. We had Cognito for authorization for our mobile users. And we use DynamoDB, let's say, to store our rights that people ordered. We start off here by just creating a bucket. So in that case, I just search for the topic for S3. Also, perhaps to highlighting here, we're also working in a specific region where we create our bucket. In this case, I'm creating a specific bucket. The name always needs to be globally unique. It's important to note here. I'm creating here my Wild Rides. And I'm lucky that the name was not yet taken. After creating the bucket, I'm just navigating to it. A sec. Also here, by default, when you create S3 buckets, when you use S3, there is no public access possible. We have a feature called block public access, where I ran into when recording the demo that I forgot about to deactivate this. So by default, you can set this up on an account level that nobody can make buckets public. Because you've heard in the press, for example, what I'm doing here, just dragging over the files, they talk about, well, AWS, Amazon, data publicly available for everybody to read. What happened? People made their bucket public. And when you make your bucket world readable, it's world readable. Okay. Good. Those are the files that are already provisioned for the project. I'm uploading the data here. The next thing I want to show you, I'm just jumping to this specific number here, is I'm setting up a certain bucket policy to make the bucket public. This is just a standard policy where we also provide a lot of examples where you don't need to write those policies yourself. Let me just check. I'm switching now over to the next part, just to speed things up a little bit. Yeah, this is the policy, so I need to specify here my certain bucket name, recognize that I cannot copy it directly, so I'm putting it in here. We also use those so-called ARNs, Amazon Resource Names, to reflect the configuration we have in the account. Good, and you can see bucket is public. We specify this now. We highlight this also in the overview so that it's clearly visible for everybody. Okay, this bucket now, the data is publicly visible on the internet. What I'm doing next here, I'm enabling the static web hosting. So to create my own website here, you see we already got at the end, S3 is a website that is accessible via HTTP or HTTPS via this link. So I'm enabling it here. Putting in this index file, at the end saving it, and that's it. Copying the information in parallel to make sure I have this available, and I'm testing this out. Good. Now I'm skipping a few steps because we're quite short on time here. In the backend, what I created here was also a Cognito pool. So I created a Cognito pool that I copied the pool ID, and I created a so-called app client for that. I put this in a config file in my S3 document, so I have this referenceable with the combination of Cognito with S3. What I'm doing next now, this is the website now. You see still the domain is up. Then doing registering. I ran into the problem that I forgot about those certain password issues, that it has a number in it and has certain symbols in it. But then I register, I get an email in the back end that I can then verify. I'm switching to this one over now. So I'm getting this email, using my email address. Yes, it's HTTP, that's not good. So we would need to have a sort of certificate to make this more secure. Good that everybody was already asking this one. So I had the verification code here, that worked. I want to dive further towards DynamoDB. So it's once again just searching for the service, accessing it. I've already have a table called music in there for testing purposes. But you see, we don't provision any servers. We just hit create table. We set up a table name. We set a certain primary key. Although DynamoDB scales in the background, you need to be aware of certain design elements of DynamoDB for primary keys, for also other indexes that you can use. So we are able to scale this in the back end for you via our partitions. So see, I'm creating this table. There is once again the ARN I'm using because I need to reference this afterwards. What I've done in the meantime, this one I'm skipping to go directly to Lambda, is I've created a so-called IAM role, Identity and Access Management, which gives Lambda the option to use certain services to execute certain API calls on my behalf, to be authorized for that on a temporary basis. Good, I need to play, sorry. So by using Lambda, I'm just going to the platform. We already also created a lot of. You can also, this is perhaps another one to important here. You can author from scratch, you can use blueprints, or you can use SAR, our serverless app repository, where we have already Lambda-based applications available for you. Yeah, we give this a name. Also interesting fact here, the original project was based on Node.js, I think version 6. This has been deprecated. We support now 8.0 and 10.x. That was the custom runtime I talked about earlier. I'm setting now up this permission, so I'm choosing the role I've created earlier, which gives Lambda the certain permissions to execute API calls on my behalf. Creating the function. So you can see here, this one is important. We have those triggers, not defined here, and we have certain events that we can also react upon to. It's important. In that case, it's nothing more complicated than at the end, just copying the code. When you have created a function for that, just copy in here. We have a code editor here. Typically use this export handler to work with Lambda. Save it. What I'm doing next is also creating a certain test event to see, okay, if it works. You can create different test events that are run via the management console or via programmatically if you want to. Switching now over, what I can then look at is, where is it? I just need to go for that. To API Gateway. With API Gateway, remember this was our front door we deployed to manage our APIs. So you can create your own APIs, you can version them, and what I'm doing there, I'm just increasing a little bit the play speed here. This more, so you can use this getting started. We already imported, we're now giving you example APIs that I was kind of confused about because I've gone into this one again. In this case, I'm creating a new API then to be used, give it a name. I've given also an endpoint which I will choose edge optimized, which is ideally for applications that run close to the customer, that run on a global scale where I do not know where my customers are coming from. This is typically the way. I also like API Gateway because it gives me kind of this visual representation. I'm speeding this up a little bit on how this looks like. So I'm creating the authorizer, which is Cognito, remember. I'm copying the code here. I'm moving forward a little bit. Then I'm creating my different methods, my actions. Let me just skip towards this next one here. And at the end, this is like my write, my API, which is initiated by a /write, where I have my clients, where I have my Lambda as a requester, as my request unicorn function, and I see this visually. This is something for me always from a certain code. Okay, for sometimes if you're the hardcore developer, you typically already know, okay, what is happening there. For me, it's good to have a visualization of that. Good. I'm using then the code, and let's have a look. When I'm then using my application, so this is at the end the finalized version, which is fairly easy to start with. But of course, I'm not using Seattle here, which is by defaultly set up. Yeah, come on. Of course, quite close. Request a unicorn. Shadowfax, our white unicorn is on our way. Yes, we can giddy up on that. So this was the kind of short demo for that one. It's a standard open project. I will share with you the link afterwards so you can rebuild this, customize it to your own, and have a starting point to work with serverless architectures. Okay? Good. I'm just switching back to my slide. I will skip upon those. I just want to highlight you to bring this to an end. This one here, if it's switching correctly, experiment and learn. I will share more additional links with you afterwards, but another link which is really important for me is this one here, AWS.training. Feel free to use a lot of our free services to learn with services, to also use so-called self-paced labs where you can create environments that are independent of your AWS account, where you can experiment and you can try out new things. We have different environments that you can either use our digital training platform under AWS.training. You can use classroom training classes that I'm also teaching across Germany, Austria, and Switzerland. If you're eager for certification, do certifications. We have a lot of environments where you can develop DevOps certifications. Those are highly rewarded in the industry, and perhaps polish up your already good Xing or LinkedIn profile. Also interested, if you're students or if you know somebody in the university in Passau or general students, AWS Educate gives you access to certain free credits to use on our platform, to experiment with. If you want to have a goal of certification, specifically for universities, we have a program. I know the university in Passau is not yet enrolled, AWS Academy, where we provide training material to students, to lecturers, to create a path towards certification, so that you can use, while you're doing your studies, also get hold of a certification on AWS. I was really fond of this back in my days at the Berufsschule in Passau, where I did Cisco and Microsoft certifications while I was doing my internship. Okay. Good. Also here, this is the training platform. Feel free, search for free digital training. You will find around about 30 completely free developer training courses and 13 with the focus on serverless. We use also edX as a platform, or Udacity or Udemy to publish our resources. This is everything from my end. Sorry for putting it over time. I typically don't go over time. Sorry about that. But hopefully it was interesting for you. I'll provide you with additional links here. Here's Sam again. Feel free to catch Sam afterwards in form of a sticker. Yes, thank you.